let's continue with the topic 5G communication systems and the need for computing. There are two things currently happening: 5G in the mobile communication systems and also computing within all kinds of communication networks, and we try here to bring these things together. Back for the book, what we will do now is chapter 1, more or less, talking about evolution of communication networks very shortly, that we have done already in ComNets 1. You can revise them on YouTube as well. And then we talk about the 5G communication system. So if you look back in the history of telephone network architectures, it started as a fully meshed network towards a centralized, very unique switching point over here to a more sophisticated network, a very intelligent network with dedicated communication nodes, with dedicated tasks. This was a quite successful network, but it has its weakness when it comes to resilience in case some of these nodes are knocked out, and also there are other deficiencies you will see throughout the lecture here. I gave you here the code if you would like to go to the videos of ComNets 1 again. So what you see here is the evolution of communication networks. On the left you see again the classical telephone network moving towards the internet, which is a meshed network, which is now not an intelligent network. It's a very dumb network with nodes that store and forward information with the possibility to route packets around failure nodes, and the intelligence in such a network is really in the end nodes. And what we will talk about in communication network 2 is more or less the architecture you see on the right. So where you have multiple computing entities within the network. Not all of the nodes must be equipped with computing, but a lot of the nodes will be. They have different power, computing power at the nodes, and storage capabilities. There will be still very big databases in the back. On the top you can see it here. But such a system is needed to build up the new future communication system, which is communication networks to control the Internet of Things in real time. So with that, let's start to talk about a little bit about 5G. Why 5G is so important. It is one of the small wheels that will spin the big wheel of digital transfer. There are a lot of things like Industry 4.0 or connected cars, a lot of use cases where 5G will play a role, but in the end, all of these use cases will have impact on the bigger wheel, which is the digital transfer. Now, if you want to understand what 5G makes so special, we have to look into the evolution. When it comes to 5G, we often talk about a revolution, but every new technology is introduced as a revolution. This is just to take some steam and say this is very important, you have to look at this. But you will see that 5G is special. If you look at the other 4 generations that were there before the 5th generation, which is clear there must be 4, right? Then you can look into what makes them different. Why is there a generation? They pop out every 10 years, every decade you have a new generation, and often it goes hand in hand with a use case or with a technology. So the first generation was analog, right? It was not for masses, it was given for a dedicated group of people like doctors, professors, operating, and politicians. They had access to these kind of systems. In order to make mobile communication available for the masses, we had the 2nd generation, and therefore they made it digital to bring that price down. And what they also used here was a communication way, how they communicate over the air. So how the wireless medium was used among different wireless terminals. They called it wireless terminals back then, and it's called time division multiple access. Again, if you're not familiar with this term, in ComNets 1 we are describing this, what it means. But actually the resource wireless medium, the spectrum, is given out in different time slots towards different users that would like to communicate. The 3rd generation had then a new air interface based on CDMA. It was called wideband CDMA. And with the 5th generation we had OFDM, orthogonal frequency division multiple access. And if you record what we had in ComNets 1, you find out we are running out of air interfaces. So 5G is not about the air interface, right? If you look into the services, the 1st generation had just voice. This second generation, especially the European version of it, was about voice and mobility and security. Mobility, I think you have heard about it. It was a mobile communication system where you can go over the borders from one country in another in Europe, and that made it special. That was at a time where in the US you had not only to rent a car when you entered a foreign airport, you also had to rent a mobile phone for this area if you did not have it already. So mobility was big, and security, not a lot of people talk about it, but there was a big portion on security already back in the 2G networks. 3G tried to offer first data. 2G already had something like SMS and then GPRS, so some of the small data rates, and they went also to Edge. But to have higher data rates, 3G was also looking into high data rates up to megabit per second. And there was a problem that not only the data rates were important, but also the services. There was an intermediate internet evolution for mobile internet, which did not work out. Only with 4G, the promise of having internet connections on your mobile phone was really made true, where you had the mobile internet and massive video with 4G. So this is more or less the killer application everybody was looking for. But if you look at 3G or 4G and ask, look what the people thought the killer application would have been, then you would see that it's not what is written down here. Good. So what makes 5G now is the next step. But you see already I put it a little bit under a dashed line. The reason is it will now not only think about humans. The first 4 generations looked into consumer market, humans connecting humans or humans to services like Netflix, Facebook, and others. 5G is now looking into a massive number of devices, right? You will see this later. It will have a new architecture. Here we have more or less same architectures, but here something will happen. And you also will see that this is not just an extension, a mobile or wireless extension to the core network. There's more. We call it a holistic approach with the wired world. Good. And this is the difference, really. The previous 4 generation is communication for consumers, and now we have communication for things and control. As you've seen before, there will be also a link to the wired world, while the others are just connected to the internet. Here there are some concepts that are floating around, and this you can see. There are some standardization bodies. There's 3GPP for the 5G on the wireless side, and IETF is also talking about more softwareized, virtualized networks, but they also found out the term 5G important, and now there are liaison meetings between these 2 standardization bodies to talk to each other. And that's quite funny because their speech and vocabulary is quite different. So if you look, first of all, into this kind of generations, these kind of updates you get, then in the mobile side, you will see it happens every 10 years. And on the in the wired world, there is not really a generation. If you would ask what kind of generation the internet has, nobody would really understand the questions. They might refer to IP version 4 or 6, but this is just the format. There's no generation because this part can update every day. And the reason is this is done mostly in software, while here in the old world we have hardware issues. Now, as you can see, hardware is dominating the wireless side and software the wired. And if we now combine a holistic 5G approach, what you need to see is that a lot of things will be done now in software, and hardware will play a minor role. There will be still dedicated hardware for energy efficient computing, for example, for very fast computing, acceleration, and also for the whole RF baseband, so how to send the electromagnetic waves over the air. This is done in hardware. But the rest is done in software. And it's not because software is superior, it's often even slower than the hardware, but the point is that you can change here things very quickly and come up with new services. Something that normally in the 4G world, you can only change something very quickly in the cloud and as an app on the mobile device, but you cannot change it within the network. And this is a request from the network operators that would like to look into very softwareized services within the network. So all in all, if we enter the world of software, this becomes a computing and communication question. Therefore, the book has also the name Computing and Communication Networks. And to sum up, you see here the term communication was referring just to transport. So the wireless link just was transparent information transportation of bits, where you convey bits from A to B without doing anything. But communication in 5G will look different. Communication here is the transport of bits, storage of bits in different locations, as well as computing at different location within the network. So I think this is the biggest step between the 5 different generations here. And again, the summary, what you see here, the old world driven in hardware where communication is transport, and on the other side a software-hardware combination with more tendency towards software. And then you see you get a holistic 5G that then can update the services within a day. And this is something that we would like to achieve. But later more.